let's not lose the forest from the trees. What are we doing here? Whole idea is we're going to try to solve a non-singular linear system problem with this matrix, right? That came up in a modeling experiment. And we said the way we're going to do that is we're going to turn this matrix into an upper triangular. And the way that we're going to turn it into upper triangular is to multiply by a from the left by a sequence of elementary matrices. And in this case, this matrix is regular. What the hell does regular mean? Who knows? But what we noticed is we only needed shear matrices to do that, right? Okay, so we multiply by a sequence of shear matrices. Those cancel out everything under pivot 1. Once we've done that, this element is changed. And so we multiply by a new shear matrix to get rid of everything under pivot 2. But when we did that, one of the claims that we're going to make, we're going to start to notice a trend. So it's hard to notice a trend from one case. I could have you do this 50 times, but I'm allowed 1/4. The trend that we noticed was these two shear matrices actually are married into one. And that matrix we're going to call a Gauss transform. The Gauss transform takes the form every single, basically an entire sequence of lower triangular matrices. Instead of having to do each matrix individually, what can I do instead? Pick off all of the elements in that particular column and do what with it? Put them all in the same column, right? Then this Gauss transform, so if we looked at this Gauss transform here, which is this Gauss transform here, this entire matrix, which was the sequence of shear matrices used to zero out everything under the first pivot, that thing got rid of all of these, right? Okay. What did this Gauss transform do? It actually didn't get rid of the 3.6. Why? Because the 3.6 was no longer 3.6 by the nature of this thing, right? Okay. But here's a claim. Anybody recognize this? What type of matrix is this? Lower triangular. What do you know about the non-diagonals? Or the main diagonals, I'm sorry. All not zero. What do you know about what's the claim we made about a lower triangular matrix with all non-zero diagonals? It's invertible. Invertible. Okay, so now what I'd like to do is I'd like to get all of these over to the other side using matrix inverses. Which is the first one I need to get rid of? L2, because that's the one that comes first. Does it have an inverse? We claim it's going to. We're not sure what that inverse is like. So how do I get rid of L2? Multiply by its inverse. If I multiply the left-hand side by the inverse, what do you tell me? Do the same thing to the right-hand side. Once I've gotten rid of L2, what's the next one I have to get rid of? L1. If I multiply the left-hand side by the inverse, what do you tell me? Okay. L2 inverse times L2? That's the identity matrix. So that's I2. L1 inverse times I3 times L1? What's the claim here? If I multiply all of these together, what do I get? The identity matrix. Okay. When we come back, we'll finish this. But now we actually have a situation where we're claiming that, I'll actually write this all out for us. I think it's worth doing it. Okay, so let's take a look at this. What is this one? Yeah, I think it's I3 in this case because that's a 3 by 3. I misled you the other time, right? You're right on though. You're just making sure that I was still awake because I lied to you, right? Never trust a teacher, ever, especially this one. All right, so here we go. Until you confirm that the teacher's not lying to you, and then you're like, oh yeah, you're right. All right, I3 times any matrix stays the same. I don't know which one you want to do. Does it matter? This is where things just get gorgeous. This is just like one of the, it's a gorgeous, I don't know, the people that discovered this were really nerds. It's gorgeous. It's an absolutely gorgeous thing. It's just freaking, like, how much time they must have spent, like, messing up on this, you know? This must have taken like 4 years of screw-ups, and then eventually they're like, ah, that's what's going on. And now they teach in like 2 lectures, right? Yeah. Okay, what about this? Identity matrix. So this is I3 times A. What's I3 times A? A. Yeah, I guess I'll just leave that like this. So now you've got L1 inverse times L2 inverse times U.